Good day, folks. Here's another question of work energy and power. It says a 5 kg block is released from rest from a height of 5 meters. Here's the height, it's 5 meters, it's released there. So if it's released, that means the initial velocity is 0, and then it will go down, slide down. The velocity increases up until it reaches that point, right? With the final velocity that we do not know. And then it says, sorry, it slides down a frictionless incline point to point P. So from here to here, it's frictionless, right? There's no friction, there's no conservative force. It's a closed system, right? Non-conservative force, sorry. When it moves along a frictionless horizontal PQ, it finally moves up a second rough inclined plane. So what what they mean, this is a closed system. So from the top of an incline to PQR, it's a closed system because there's no non-conservative forces that are here, right? So it would slide down in a frictionless, and then it goes down in a frictionless to Q. So while it goes here, guys, there's no other force that is acting on it, no friction. So that means no net force. So it will move at constant velocity. Now, it says it comes to a stop at point R, which is 3 meters above the horizontal. So it will climb up. Here, this is an open system. Here, it's open because there is a friction here, right? So there's a friction here, so it will climb up and decreases the velocity, and then it will stop there. The final velocity will be 0, right? So we'll take this from here. It will be initial velocity of this track. So the velocity that it will reach here by, so it will be the same, it will be constant here, and then it will be the initial there, and then it climbs up there, right? Now it says the frictional force, which is a non-conservative force between the surface and the block, is 18. Where? Here. The friction here is here, so it's 18. Now the question, it says, use the energy principle to calculate the speed of the block at P. So they want the speed of the block at P. So we are permissible, or we can use the conservation of mechanical energy when it comes to that. So 5.1, guys, instead of using the conservation of mechanical energy, you can use this formula. It says work done by non-conservative is equal to change in EK plus change in EP is the same. But what is the difference there? So the work done by non-conservative force is 0 because there's no non-conservative force, right? So you do that, and then it's going to be P. So you have change in EP is equal to positive EK. So it's going to be negative mgh final minus mgh initial, and then half mv final square minus mv initial square. The mass is here, we can cancel the masses here. So it will be 9.8 height final. The height final is 0 to the bottom, is coming from the top to the bottom, and then the initial, it's 5, and then half, and then the final velocity is the one that we want. We wanted this velocity here at P. Use the energy principle to calculate the speed of the block at P. We want the velocity here. So square the initial velocity, it started from rest, is going to be 0 square. So this side, it will be 0.5 VF squared, right? So when we punch that in the calculator, okay, let me quickly do it. Sorry about the noise, guys, my child is making noise in the living room. So it's negative 9.8 times 0 minus 5. That's 49. So 49 divide by half, and then we put the square root of an answer. It's going to be VF, it's going to be 9.90 meters per second. So it reaches the bottom here by the velocity of 9.9. Now 5.2, it says explain why the kinetic energy at point P is the same at point Q. As I've mentioned earlier, guys, as it reaches the bottom here, the velocity increases. When it gets to this point, and the velocity will be constant here because there's no other force there. So the answer there, it will be no net force acting on the block. Okay, let's say no net force or no friction acting on the block. Right, no net force, no friction acting on the block, because no other force that is acting there, and that surface is frictionless. So no loss of energy. There's no loss of energy there. Now 5.3, it says explain the term non-conservative force. A non-conservative force is a force in which the work done depends on the path taken. Check the exam guideline when it comes to that. 5.4, calculated the angle of the slope. So we want this angle of the slope. Guys, one thing that we know, this velocity that we calculated that it reaches here, it's 9.9. It's going to be 9.99.9 constant until there. So the initial velocity there, it's 9.9 meter per second, and then it decreases to what? To 0 there at the top. So that's what we know there. Now it says we must calculate the angle of the slope. So what I'm going to use there, it's the energy principle, which is 5.4. I'm going to use the work energy theorem there, right? So what are the forces acting on that object as it moves up there? There are two forces. Remember, there's a friction present here that is going down while the object is moving up, and there's a gravitational force, which is the Fg parallel. So we'll say work done by frictional force plus work done by Fg parallel is equal to change in Ek. And then work done by Fk, remember, when you do not have the what is called the angle, you see here, we required to calculate this angle. We're not given the displacement, we're only given the height. So you can change the work done by gravity by negative change in gravitational potential energy. You are allowed to do that. Check my other videos. And then we will say here Fk, change in x cos theta, minus mgh final minus mgh initial is equal to half mv final square minus initial square. So the frictional force we are given here, it's 18, and the mass of an object is 5, and the height is 3. So it's 18. The displacement we do not have there. We'll just put dx. We'll have to first find the displacement. It's going to be cos 180 because it's going in opposite direction, and the mass is 5 times 9.8, and then the height final is 3, the height final where it reaches r, it's 3. Initially it was 0 height, so equal to half, the mass is 5, and the v final is 0, and the v initial, it's 9,9 square. Right? So what's going to happen here, when you punch this in the calculator, you do your math there, you will get the displacement first. The only unknown here is the displacement, so your displacement, it will be 5,44 4458 meters. I'm not going to round off that answer because I'm still going to use it. Now from this we have the displacement, we're looking for that, so we have two things basically. We have that, and we have the height, it's 3 meters, and we're looking for that. We have the displacement. Now displacement, it's 5,4458 meters, so we're going to use the sine. Sine theta is equal to height over hypotenuse. The hypotenuse is the displacement, and then it's going to be sine theta is equal to, our height is 5,4458. So we'll do the arc sine there. Arc sine is going to be 3,54458. So it's going to be, when you punch that in the calculator, it will be 33,43 degrees. That's the angle there. Let's look at it another way, using another pen. Let's look at it another way. What if we have used the work done, this, we have used the same, but instead of changing the work done by gravitational force, and we keep it and see what's going to happen. Right now it's going to be the work done by friction, change in x cos theta, and plus, okay, let's look at that triangle without. So the only thing we want, this, we are only given h, which is 3 meters, and the displacement is unknown. Right? So looking for an angle there is sine theta is equal to 3 over displacement. Right? So our displacement here, it's going to be the displacement, it's going to be 3 divided by sine theta. That's our displacement. Okay, let's see how it's going to take us with that displacement. So it's going to be mg sine theta, that's fg parallel delta x cos theta, equal to half mv final square minus mv initial square. So we do have, we don't have, and here's our unknown as well. Our unknown as well, this is our unknown, and this is our unknown. Let's see if we cannot get away with that. So we'll have 18, which is fx, and the displacement here is going to be 3 sine theta, and then cos theta, plus, and the mass is going to be 5 times 9.8 sine theta, and then the displacement is going to be 3 sine theta cos theta. Okay, let's minimize this, right, like that, and then it's going to be 5 times Vf final is 0, and the initial is 9.990 square. Right, so this side, what's going to happen here, we're going to have that Okay, what I forgot here. This is supposed to be cos 180, right? So we're going to have here, when I punch that in the calculator, we're going to have um, um, 18 times 3 is 54. So we're going to have 54 over sine theta, and it's going to be negative with this negative 1. Hope you get that math. So this and this will cancel. So we'll have 5 times 9.8. It's that. It's going to be 49. And then the FG parallel is going down as well. So here it's supposed to be cos 180 as well. So it's cos 180. So this will be negative if it's cos 180. This will be negative. So times 3. So it will be negative 147. This. So that's all on this side. I hope you get that, guys. So this is going to be 0.5, which is half times 5 times 9.9 square. It's going to be 245,025, right? That's the math there. Okay, let me do it this way. Yeah, that's what we're going to have. This is going to be negative, and I take this to this side. So I'll say in the answer plus 147. So this is going to be negative 54 sine theta is equal to negative 98,025, and then we cross multiply. So it will be positive negative sine, no, it's going to be 98,025 sine theta equal to negative 54 when I cross multiply there. Hope you get that math. So we'll say 54 negative divide by answer, which is the answer is 98,025. Okay, so we divide by 98,025 both sides, 98,025 both sides. So your sine theta 0.550 8798. Okay, I'll keep it in the calculator, and then I'll say arc sine. Okay, I'll say arc sine answer. So it gives the same 33,43 degrees. It's the same. I hope you get that.